Good afternoon, everyone, and welcome to Horticultural School webinar series. If you have any questions during the presentations today, please type them into the questions section of the GoToWebinar menu, and we will answer them at the end of each presentation. If we don't have enough time at the end of each presentation, we'll take the remainder of the questions to the end of the entire presentation. This webinar is being recorded, and you will receive a link to the recording. Thank you.
Thanks very much, Lori. My name's Tom Gonzalez. I'm the vegetable crop specialist with Manitoba Agriculture. I'd just like to welcome you to the first of this year's Horticulture School webinar series. Over the past few years, we have presented extension information in an in-person format at the annual Horticulture School. As we're all aware, COVID-19 has caused some restrictions on how we and our partners at AFC and at Assiniboine Community College are able to provide extension information to industry. This year, we decided to try the webinar format, and today's webinar is the first of 6 in the 2020 Horticulture School webinar series. So I hope you enjoy it. Let us know either way what you think. Our first speaker today is Colleen Flynn. Colleen is Manitoba Agriculture's pesticide, minor use, and regulatory specialist, who will be speaking on pesticide incidence reporting.
Good afternoon. Hope everyone is doing well on this Friday afternoon. My name is Colleen Flynn, and I'm the Pesticide Minor Use Coordinator and Regulatory Specialist with Manitoba Agriculture. Today, I'm going to briefly talk about how pesticides are regulated federally and provincially. Hopefully, you haven't had to deal with the pesticide drift issue, but if you have, I will go over the process of what to do and who to contact if a pesticide incident occurs. I will also talk a bit about some of the ways that you can prevent incidents from happening. And when I'm talking about prevention in this presentation, I'm not talking about prevention from the aspect of the applicator spraying, who of course would be paying attention to things like product label, wind speed, temperature, humidity, nozzle size or distance, operating speed, and tank volume, but as the grower that is not wanting their sensitive horticulture or fruit crop to be sprayed on. I will leave time for questions at the end. So how are pesticides regulated? Pesticides are regulated both federally and provincially. The Pest Control Products Act is a federal act. This act regulates pesticide registration. Primary objective under the Pest Control Products Act is to prevent unacceptable risks to people and the environment from the use of pest control products. The federal people are in charge of everything related to the pesticide label. Off-label applications would be an example, sale of unregistered products, and issues of those nature. At Manitoba Agriculture and Resource Development, we regulate the Pesticide, Fertilizer and Control Act. The purpose of the Act is to ensure the safe and proper application of pesticides and manures through the education and technical support to dealers and applicators. The licensing of pesticide applicators and pesticide dealers are under this Act. Manitoba Conservation and Climate regulates use of pesticides under the Environment Act license and pesticide permits. The pesticide use permits can be issued to a number of sectors and focus on areas where there may be a high potential for human and bystander exposure. Again, the goal is to ensure that pesticides are regulated in a manner that protects the environment and public health. So, Manitoba Agriculture issues licenses to pesticide dealers and applicators who sell or apply commercial pesticide products. Farmers are exempt from this licensing. The insurance required for pesticide licenses include $250,000 for general liability and $25,000 for chemical misuse or spray drift. This flow chart illustrates how a pesticide incident can impact a number of different areas. Each of these areas are handled slightly differently, but are all important. I will go over the human, animal, and environmental processes and protocols first, and then I'll spend a little more time on crops and plants and what to do if your horticultural crop ends up in a situation where, despite best efforts, a spray incident has occurred. Lori, can I have you launch the first poll question, please?
You bet. All right. Okay, so the first poll question is, have you ever had an issue with spray drift? Please select one and then submit. So yes, no, or unsure. If you could just submit your question, we're at about 19% voted, or your answer, I suppose. 29, we'll leave it open for a couple more seconds here. And just one, please just select one. All right, okay, so I think I will launch the results. Okay, so the results are 33% have said yes, 56% have said no, and 11% are unsure.
Oh, okay, well, that's good to know. So there is some things that are occurring, and we want to minimize our spray drift if at all possible, of course. So first, I'll talk about how to handle pesticide incidents from the human and animal standpoint. And first and foremost, you want to ensure that the health and welfare of the person or animal that was affected is okay. And so you would make sure that the people exhibiting symptoms, you would call your healthcare provider or your poison control line. And of course, if animals were exhibiting symptoms, you would call your veterinarian. Following this, once all are safe, there's a Health Canada incident reporting site that directs information specifically to PMRA, and any incidents involving humans and animals or the environment should be reported to Health Canada. I've provided the links on your screen so that you can reference them later, as well as a telephone number. It has a site specifically for the incident reporting site, and also there's also a site where you can get further information on specific chemicals. So for handling pesticide incidents related to the environment, first and foremost, environmental emergencies would be reported to the province's environmental emergency line here in Manitoba. And an environmental emergency is defined as any release or imminent release of a contaminant that may pose a risk to public health or the environment. For example, a chemical spill. Any other pesticide issues that aren't emergencies can, of course, be referred to the local environment officer within the Department of Conservation and Climate. So now I'll talk a little bit more on the agricultural side and horticultural side, handling pesticide incidents with crops. Manitoba Agriculture does not get involved in site visits. In the past we did, but we do not do this. And we don't get involved in arbitration. Instead, we help with documentation and as well as provide extension. One of the first questions to ask is it a farmer or a commercial applicator? Commercial applicators need to be licensed in Manitoba, and they're regulated under the Pesticide and Fertilizer Control Act. It's also important to speak to the applicator. Documents that you need or types of information that you need to collect include what pesticide was applied, what was the target crop, what is the non-target crop and the injury. Take detailed notes. If you can include pictures with date stamps and descriptions, that's even better. Store and send your samples for testing. You need to collect your samples immediately and store them in the freezer until testing can be done, or collect the samples and send them immediately to an analytical lab for residue analysis. Plant samples can also be sent to our Provincial Crop Diagnostic Center for visual diagnostics. Tammy will talk about it a bit more in the next presentation about the complications of using visual analysis, and I'll just leave that part to her. So this flow chart shows the difference between how incidents are recorded with farmers and commercial applicators. In both cases, it's important to find out, was the applicator contacted, what the target crop is, and what pesticide was applied. So for a farmer, for the reporting process for the farmer, site visits aren't offered. You can fill out the page 1 of our pesticide incident reporting form that we have at Manitoba Agriculture. Again, we don't do arbitration, and to pursue the case further, we would suggest taking immediate samples, and those samples can be sent to the diagnostic lab or other labs for residue testing, and the farmer can also use an independent agronomist to help him with this process. When we're looking at a commercial applicator, again, site visits aren't offered. For a formal complaint, they would fill out page 1, 2, and 3 of the form, and the similar instructions would apply to the farmer in steps 3 to 6. If a formal complaint wasn't launched, it would just be filling out that first page. So when an incident is filed with Manitoba Agriculture for a commercial applicator, we would verify the applicator's license. We would collect and investigate the relevant pesticide application records to see if there was an infraction incurred under our act. And a record of complaints is kept in the applicator's permanent licensing file. So that would be, and if there was a number of if there was a number of complaints or a serious complaint, there can be fines, or the licenses can be revoked or suspended. If there was a label violation, which is a federal violation with PMRA, we would cooperate with Health Canada's PMRA or Regulation Operations Enforcement Branch. So I won't spend a lot of time on this. This is the first page of our pesticide incident reporting form. Collects the client information, the nature of the incident, and details involved. This is the more formal incident reporting that would be filled out. This is the pages 2 and 3, and these forms again are kept on file. This is the contact information for our provincial crop diagnostic lab, which provides extension and ag services for agricultural crop production. Drop off of samples is usually between 9 and 4, and there is a diagnostic form that you fill out and submit with your sample as well. So the next 2 slides have contact information for labs that do analytical pesticide analysis. I've included this in my presentation so that you will have the contact information necessary if you need to contact them in the future. This isn't an exhaustive list, but this is some labs that we use. They each have slightly different forms and instructions for collecting information. It's always best to contact them ahead of time to get instructions before submitting specific samples. Pesticide residue samples are generally quite expensive, ranging from like $180 to $350. So you want to make sure you're collecting your samples correctly and shipping them correctly. So, prevention of an incident. If we can prevent a pesticide spray drift issue, that is the best. Communication ahead of time is crucial to this. It's really important to open up a dialogue with your landowner or producers renting land adjoining your property. You can make note of your concerns, point out environmentally sensitive areas, perhaps some waterways, and even residences. You can also ask to be informed about applications so you take precautions about inadvertent exposures. You can do things like closing windows, moving people inside, moving animals into barns. And prevention against exposure is a good investment and time well spent. It really truly is important to communicate with your neighbors. Another form of prevention that is also being used to prevent pesticide drifts are vegetative or structural barriers, as well as using buffer zones on your own farm. I will be referring to information on vegetative barriers from our friends in Omafra, Todd Ludy and Jason DeVoe, and I have included a link to Jason's presentation that he gave on vegetative barriers to reduce pesticide drift for information. There's a lot of good information in there. So these 2 pictures show windbreaks reducing, the top picture shows the top picture has vegetative barriers planted around an agricultural field, and these are known to protect sensitive crops from damaging winds and also help reduce spray drift. This picture is courtesy of Todd Ludy from Omafra, as well as the bottom one. The bottom picture shows a mixture of trees, coniferous and deciduous trees alternating in a tree row. So it's a good idea to plant more than one species for the overall health of the vegetative barrier, and it gives different densities for windbreaks and barriers. In addition to windbreaks and vegetative barriers, as a grower, you can consider making a buffer zone on your own field. Organic farmers quite often will leave a buffer zone in their own field, so they're not relying on their neighbors for that buffer zone, but they have it built into their own field. So I took this information from a presentation from Jason, aka Spray Guy from Omafra, And although I don't have time in this presentation to go into detail, I can highlight some of his take-home points from his presentation, and I provided a link so that you can go and watch it as well. So some of the suggestions to have good vegetative barriers that reduce pesticide drift were that vegetation from the ground all the way up to the crown with about 50% visual porosity is the best. Also, you should use mixed plantings to ensure there are no gaps in the lower canopy. And needles beat leaves. I thought this was interesting. Trees with needles and small hairy leaves are better at intercepting pesticide droplets, and this was based on some research from Marikov in '96. It was also suggested that barrier height should be a minimum of 2 times the release height of the pesticide, and barriers should be as close as possible to the spray zone. Using a combination of wide followed by narrow barriers gave the best protection. Jason also mentioned that the University of Guelph used vegetative barriers in combination with snow fences and had some promising results. The bottom 2 pictures on this slide show a visual of how vegetative barriers can decrease the concentration of pesticide drift in both wide and narrow barriers. So, in summary, pesticides are regulated both federally and provincially. Hopefully, you don't have to be involved in a spray drift incident in your horticultural or fruit crop. Prevention against incidental exposure is a good investment and time well spent. Talk to the producers or the people renting the land beside you. Make note of your concerns to them. Consider planting a vegetative or structural barrier to protect your sensitive horticultural or fruit crop. Perhaps add a buffer zone to your crop or field so that you're not relying on your neighbors only. And if all else fails and you do end up having a spray drift issue, I hope I have given you some tools and contacts to help you deal with the issue. If at any time you have questions or concerns, you can contact myself, and our weed specialist Tammy Jones will be going into some of the more specifics on spray drift symptoms and show you some cool visuals and provide you with more information on this complex topic. I do have time for a couple of questions if there are any questions.
Okay, Colleen, I actually do have a couple questions. I'm not sure I'm going to be able to get to all of them, but if I don't, I will get to them at the end of all the presentations to ensure we have enough time for all of the presentations. So question number 1, how do I collect a sample for pesticide analysis?
Okay, samples should be taken immediately, and those should be frozen, and if you were sending them, it'd be sent overnight on ice if possible or in a cooler. The best thing to do is to contact the lab ahead of time because they usually have specific forms and specific instructions for sampling and shipping, and they can also, of course, at that time give you turnaround prices and times as well. You need to be specific on what you want analyzed. That's also very important, and the analysis can be quite expensive, up to $350 for some. And in general, again, you should contact the labs, but approximately you would need about 50 to 75 grams of soil or vegetation, fruits or vegetables, and usually you would pack this in a Ziploc bag. Like a medium Ziploc bag would probably be a sufficient size sample, but again, it's important to contact the lab just to verify that. And again, taking the samples immediately is very important. If you can't send them right away, then please freeze them.
Excellent, thank you. Next question, if spray drift occurs on my fruit trees before harvesting, who should I contact to see if they're safe to eat?
Okay, that's a good question, and it's a situation that we don't want to get in, so hopefully this doesn't happen very often. But the best place to start with that would be PMRA, as they're the most closely involved with product labels and registration. Earlier in my presentation, there was a contact email and a 1-800 number that you could use. Of course, it would really depend on the type of product that was sprayed. It's important to have that information. And in addition, spray drift would usually occur at a lower concentration than it would if you were treating a crop, but it can easily get quite complicated. So for example, if the product that was drifted on from an agricultural field crop, or the product used on an agricultural field crop drifts over onto your, say, Saskatoon bushes, that product might not be registered for use on that crop, so there would not be specific label use information for that crop, like residues and pre-harvest intervals. So, but PMRA has a lab with information and lots of information on pre-harvest intervals and residue limits on all the labels, and they would be your best place to start. In addition, as they're a federal organization, they might even work collaboratively with Canadian Food Inspection Agency. Of course, each situation would be slightly different, but that would be the best place to start.
Excellent, thank you. And Colleen, we do have a couple more questions and we can get to those at the end of the presentations today. So, all right, Tom, I will be moving over to Tammy.
Okay, thanks very much for your presentation, Colleen. Our next speaker for today's webinar is Tammy Jones. Tammy's the Manitoba Agriculture Weed Specialist, and her topic today will be herbicide injury.
I tried to keep it as vague as possible. That way, no expectations. Thanks, Tom. Okay, so let's get right into it because Colleen suggested that she would be 15 or 16 minutes and she rounds up. I'm not sure. Anyway, so what are herbicides? They're a chemical substance that is used to eliminate unwanted plants. And unfortunately, at times they impact on plants that are wanted, which is what we're talking about with herbicide drift. So some of the herbicides that we are familiar with would be the 2,4-Ds, MCPAs, bromoxynils, all those types of things. But there are some other ones that get used more frequently in a market garden situation, or in a lawn care scenario as well, which are like the citric acids and the chelated irons and the acetic acids, and even something like corn gluten meal, which can be used in an organic system, almost like a mulch to prevent weed emergence. So lots of different ways that herbicides are used, and that impacts on the timing of application, so pre-emergence or post-emergence. And when we're talking drift, we're talking post-emergence, but sometimes those pre-emerge chemicals may have drifted into an area too, or they may be present in the soil as a herbicide carryover, and that can impact on crop growth as well and complicate the situation even more. The activity, contact or systemic, we're going to delve into that a little bit more. Selectivity, whether it's non-selective and it kills everything, or whether it has more activity on grasses or broadleaves. We'll also look a little more into that, and then talk a bit about the mechanism of action. And so contact herbicides, when we're looking at spraying scenarios where there may be drift injury, contact herbicides are those that cause injury only to the plant tissue that actually is in contact with it or where it's applied. And so that herbicide isn't really translocated within the plant all that much. And so whatever you notice initially for damage with a contact herbicide is probably all the damage that you're ever going to see. Conversely, translocated herbicides are something that is systemic, is going to move throughout the plant. Those are either going to be phloem mobile or xylem mobile. They're either going to accumulate at the growing point or maybe in the older leaves, just depending on whether it's the xylem or the phloem that they're moving through. So that will impact on where you see your symptoms first. And it will also impact on whether you see intervenal chlorosis or whether you see it in the veins first or that sort of thing. So lots of different scenarios that can happen, and so you're going to see complexity within the damage that you might see at the plant level. So when it comes to mode of action in respect to herbicides, it's basically the way it kills the plant. Theoretically, it's hopefully only the weed, but in some cases, all plants. And so when we dig into that a little bit deeper, we're really talking about everything in that sequence of events from when the herbicide first drifts onto the non-target plant all the way until that final effect, which could be plant death. That includes everything from how it's absorbed or how much is absorbed, where, when and how it's translocated, metabolism, which comes into play really significantly when you're talking about timing samples. If a plant breaks down that chemical before or metabolizes that chemical before you have time to get a sample for residue analysis, there's not going to be any actual analysis that can be done because the metabolism will have already broken down that chemistry. And so there's quite an interaction and it becomes fairly complicated. So a mechanism of action in respect to herbicides is the actual specific biochemical or biophysical reaction or series of reactions that does cause that injury. generally the site or process is known, but there are some herbicides where that exact mode of action has not been determined. And currently we're at about 28, 29 different modes of action. And hopefully, as a weed scientist, we're always looking for new modes of action so that we can kill more weeds. And so we'll hopefully see more modes of action over time. So this chart that I'm showing here is one that's taken directly from the Guide to Crop Protection or the Field Crop Protection 2020 guide. That being said, it applies to all sorts of plants, and there are several variations of this. But I just wanted to give you an idea of how complex it can be when you're looking at symptomology and trying to diagnose it. And so if we look at group 1 herbicides, for instance, those are graminicides. They're things that work on wild oats, and they will kill wheat certain times, although there are selective herbicides that will kill wild oats out of wheat. So again, complex and how it works. But with a group 1, it is translocated to the growing point. So then you see reduced growth, yellowing of that growing point, and within about a week to 10 days, you can pull out that grass leaf that's right at the growing point, and it'll have browned and will no longer be intact, and that's an indication that that herbicide is working on the target weed. Now, if you have a grass of some sort that is a non-target, it will have the same sort of herbicide symptomology. Group 2s are a little more complicated. There is typically most activity on broadleafs, but there are some grassy species that are impacted by it. So again, if you're looking at herbicide injury within an area and you're wondering why are only certain weeds impacted or certain plants impacted but not others, it could be because it's only active on certain broadleaf and certain grass weeds. Now, group 2 symptomology we'll get into in a second. You'll notice here that it says red, yellow, or purple as being typical in broadleafs, and I'm going to show you that not all of that happens every single time, and in fact that isn't the only symptomology that you might see within broadleaf weeds or broadleaf plants in general. And if we advance a slide here, you can start to see that there's lots of different herbicide groups, various modes of action, depending on whether it comes into contact through the roots, through the foliage, whatever the case may be. It can be bleaching, it can be necrosis, chlorosis, all sorts of symptomology. And so that leads me into my real Debbie Downer slide here, which is why is it so difficult to determine what herbicide has maybe been drifted on here, or if in fact it is herbicide injury. And so there's difficulty in determining symptomology because within a herbicide group, you will see different symptoms, but you'll also see it between different groups. And there's a wide range of symptoms that can be produced by a single herbicide within a bunch of different plants. And similar symptoms can be caused by something completely unrelated to herbicides. And the other thing to keep in mind is that most field applications of herbicide, because of resistance management or because of a broad spectrum of weeds that they're trying to target, most of those herbicide applications will involve multiple tank mix partners, making it even more complex. Okay, so let's look at some herbicide symptomology because I've set you up for disaster in that it's going to be a real challenge, and here's a good demonstration of it. 3 different times when there's assessment of herbicide injury. And if we look at this first picture here, I'll get my laser pointer going. This is very early on with group 2 injury in canola, but you would see it with very similar with cauliflower or any of the brassica type species. So you're seeing some yellowing that will end up being chlorosis, or is chlorosis that will end up being necrosis. And when we get into this picture, this is further along, and you can start to see that there's yellowing and maybe a little red, which is very symptomatic of group 2 injury, but not the purpling that I had mentioned earlier, and that could be a timing thing. I might have taken this picture too late, whatever the case may be. In comparison, so that's 2 canola plants at different times. This particular picture here, this is group 2 injury in sunflower, and that's actually the flower bud or the first part of the head formation where we're starting to see malformation. Now, the group 2 product was applied a long time ago, and it's just at the time of flowering within the sunflower crop that we're starting to see an indication of injury. by this time, if you were to take plant samples and do tissue analysis, it would be really challenging to find any metabolites of the group 2 in there. And it's just because we have this malformation that we have an indication of any type of injury. So those are all group 2 products. This is some of the varying symptomology that you can see with group 4 products for the most part. So epinasty is one of the fun things that happens with group 4s. They're auxin mimics, so the plants sort of grow themselves to death in a way. And so you can see in here this spaghetti stuff, that is actually the stalks of the flowers of the dandelions that are twisting and curling. Now, just for fun, I've added this one in here. You'll notice that there's some reddening and purpling on the dandelion leaves. That's because this is actually a group 4 and a group 2 together. And so you're seeing a complexity in the symptomology because we have 2 things together. So pure, straightforward epinasty, this is in a pea, and this would have been a field pea, but it would be similar for a processing pea in that you would see very, very similar symptomology with the epinasty. And then again, like I had demonstrated with the group 2s, with these group 4 products, sometimes it becomes brace root formation that is impacted. So this is corn that had been sprayed with a group 4, and it wasn't epinasty that happened within the leaves or anything like that, but simply some malformation in that brace root. So very different symptomology depending on which part of the plant you're looking at or which plant is being impacted. So some other typical symptoms for symptomology within the group 4s, and this is a great picture from Vikram, and you can see that one plant is impacted and the next plant isn't impacted. That happens quite frequently because of the deposition of herbicide. If it's in an inversion and off-target movement that way, then sometimes it's just hit or miss which plants are impacted and which aren't. So I appreciate that Vikram provided me with this particular slide for a couple of different reasons. Great symptomology, you can see epinasty and leaf cupping and that sort of thing, but also just the randomness of one plant being impacted and the next plant not being impacted. And this is actually a red root pigweed growing point that is impacted with a group 4, so some interesting symptomology here that wouldn't be typical of what I would expect for group 4 symptoms. So I added it in just to, demonstrate how challenging it can be. The reason for these, a couple of different reasons. This is dicamba on soybean, and you will notice that all of the trifoliates that were emerged at the time that the drift happened are fine. There's no symptomology on them. It's on the new growing point where that active ingredient has been translocated to where you have evidence of that symptomology. Now again, the lag time between when the application happened and when you see the symptoms may mean that there isn't a lot of chemical residue left. And so testing might be challenging in order to indicate that there actually was spray drift that happened. And so that may not always give you the answer that you're hoping for. And so this is in soybean. Anthony Manteco gave me this particular picture of strawberries and group 4 symptomology in strawberries as well. So fairly interesting symptomology, some sort of striations. And if I go to, it's a little bit later. Notice how this is kind of crinkled in here. We'll come back to that in a different slide that'll sort of confuse you even more. And that's really all I seem to be able to do is give you the non-straight answer. This is glyphosate in a couple of different situations as well. So Vikram showed me a sublethal dose of glyphosate in potato. And here you're looking at some chlorosis, but not actual death of the plant. So it'll slow it down. On the other hand, Anthony provided what is damage on raspberry and with glyphosate as well. And you can see some reddening and then some necrosis happening on this. And that may lead to death, or it may just be a setback depending on the dosage of glyphosate that that plant received. On a different kind of symptomology, this is bleaching of plant tissue. And one is in a canola plant, one is in a flax plant. And the reason that I wanted to show both of these is one's a group 13 that came from the soil. The other is a group 27 that was a foliar application. Very interesting, similar symptomology, but from completely different modes of action. So again, adding to that complexity. And then this is group 6, bromoxynil on corn. So bromoxynil is registered in some corn hybrids, not all of them. Certainly on a lot of field corn hybrids were okay as a post-emergent application, but those leaves that actually did come into contact with a high dose of bromoxynil have some burning, but anything that comes out afterwards that isn't in contact, you can see there is no translocation, no damage on the rest of the plant tissues. To add to it just a little bit more, Anthony mentioned that there's differences between cultivars within a particular plant that can have an impact on sensitivity. So the strawberry cultivar Kent is sensitive to Sinbar, which is a group 5 herbicide. Now, Sinbar is registered on a bunch of different horticulture crops, including strawberries, and yeah, there's a fairly lengthy list actually. But when it comes to this group 5 herbicide, the cultivar Kent shows some of the same symptomology that you would expect in a sensitive species, and that's some initial browning on the leaf margins, and then you do end up with interveinal areas of the leaf having a nice brown. Now, to me, that almost looks like a, you know, an ornamental plant, but apparently if you're a strawberry producer, you wouldn't be happy with that damage. Okay, so this goes back to what I was showing earlier on that strawberry plant. This is a soybean plant, but this is not a herbicide injury. This is actually rapid growth syndrome in soybean, and it's taking place on some of that newer growth as well. And so sometimes really challenging to differentiate between something that's a herbicide cause and something that's either environment, or it could be disease or insect damage, or nutrient deficiencies, or even nutrient toxicities can also cause some interesting problems in plants. Okay, so when it came to spray drift, there's a couple of different sources of spray drift. One of them is volatilization, where you have vapor drift due to either the formulation, or it could be a temperature type of a scenario. And so one of the things to remember, whether you're the one applying or whether you're looking at the application that was made by someone else, is the formulation. So was it a low drift formulation, like an LV formulation, low volatilization? Those are still not zero volatilization. They're just a lower lower susceptibility to volatilization formulation than some of the others. And then temperature. Some of the hotter it is, and with relative humidity added into there, you can see more evaporation, and then chances are more off-target movement. And then when it comes to particle drift, we're talking straight up movement of spray droplets, and that's what I'm demonstrating here. This was me with some fairly fine spray droplets of glyphosate that drifted into, for me, it was a wheat plot that I was trying to work with. And you can see just the randomness of the pattern. And I think that's important to notice as well, is that even with spray drift that's a physical spray drift rather than off-target movement, that pattern can be quite unusual, maybe not exactly what you're expecting. Okay, so some of the things that affect drift: inversions for volatilization, relative humidity can have an impact on that as well. Wind speed and direction have two impacts. When it comes to volatility, the dead calm is terrible. You do not want to spray when there is zero wind, because you're more likely to see some kind of volatility, evaporation, and off-target movement. So typically we suggest that as long as there's a breeze of maybe 3 kilometers an hour, you're okay. But anything that's less than that might be too calm and might increase the chances of there being some off-target movement. Now, when it gets to physical drift, then it's wind speeds more than, say, 20 or 25 kilometers an hour that we're really worried about. And that's when you start to think about how do you impact on that with perhaps your droplet size. So make sure that your droplets are bigger so that they have a harder time to be blown around. And you can do that through a nozzle selection and through the pressure that you're spraying with. Boom height. The lower the boom is, the less likely that you are to get those particles caught up in the wind and move them somewhere else. And then a physical shield, unlike Colleen talking about, you know, your buffer strips and maybe some trees, I'm talking about on the sprayer itself, spray shields or a shroud. And when you're looking at a backpack sprayer, one of the suggestions for a really handy dandy, easy to make shroud to concentrate or focus that spray is to cut the top off of a pop bottle and use that sort of funnel as your shroud if you're really needing to. Now, when it comes to droplet size, I mentioned nozzle type. Typically, when you're applying it at with a backpack sprayer, you don't have a lot of different nozzle types that you're working with. Certainly at a field applicator or a custom applicator, they can go to coarse and ultra coarse types of nozzles. They can decrease their pressure. The more pressure you have, the more drift you're likely to have because your droplet size becomes more fine because you're pushing it through that nozzle harder. So the ideal droplet size is between 150 and 400 microns. Anything less than 100 is increased risk of drift, and we call those driftable fines. And so a raindrop is very large. Something like this here is very fine and much easier to drift. So some considerations for that. Now, to just kind of tie it all back to what Colleen presented about and adding in some of the complexity of the herbicide injury that I saw, when you're investigating your herbicide injury, it's really challenging to focus on the facts, but you absolutely have to. And you have to make sure that you're not making snap judgments. And one of the things that Tom has taught me about the hort side of things is that tank contamination is so easy to have happen. And so having a dedicated sprayer for just glyphosate and a dedicated sprayer for just something else makes a ton of sense, because that way you can avoid tank contamination, which might be the source of your injury rather than drift or other causes. You need to ask lots of questions, gather as many details as possible, and Colleen went into some of that as well. Then look for your patterns. If there's symptoms on the plant, are they in the field and the area of suspected drift? Which plants are injured? Which ones aren't? Is there a pattern? Is it a strip? Is it an elevated area? Is it a low area? Are there areas of spray overlap that show increased symptomology that you can use as a way to assess? Is there an untreated area so that you can see that there's no damage? And then again, watch for lookalike symptoms, whether it's nutrient deficiency, fertilizer toxicity, maybe insects or disease that are causing the problem. And weather-related injuries can be anything from drought to flooding to just being too good at growing conditions and you start to get funny looking leaves that way. And so I'm going to wrap it up and say that I think I've made the path really clear, just as in focus as this weed is on this road. I think I've muddied the waters with the complexity of this. I refer to a couple of different books. How Herbicides Work, From Biology to Application is one that I use, and Recognizing Herbicide Action and Injury is another. But there are lots of resources out there, and it's really important to try to get as much factual information as you can before you jump to any conclusions with herbicide injury. Okay, I'm going to wrap it up there.
Thanks, Tammy. I do have a couple questions for you, and there are quite a few, so we'll get to two of them right now. How do you tell the difference between herbicide damage and nutrient deficiency?
So John Hurd and I have long conversations about this. One of the easiest things for me is to look at the spectrum of plants that are in that area, and if it is impacting on all the plants, then maybe it is a nutrient deficiency rather than a selective herbicide, because although it could be a non-selective herbicide, so I can argue back and forth with that, but also looking at the roots and the shoots just to see for symptomology. Typically, if it's nutrient toxicity, it will be in a row situation and you will be able to find fertilizer or something close by. Again, it's about looking at patterns, digging things up, and gathering as many facts as you can.
Okay, great. Second one, what horticulture crops are the most sensitive to herbicide damage or receive the most drift complaints?
I think tomatoes are a magnet for every herbicide drift thing that is out there. I would say that that's the one that I find the most times that we have questions about, And I would think that maybe potatoes are probably one of the more resilient ones. Even though they will show symptoms, they tend to outgrow it a little bit better, whereas tomatoes are, yeah, they're my least favorite herbicide injury plant.
Okay, great. There'll be another question at the end, so stick around and we'll get to that one. But in the meantime, John, we're going to assume that you are ready to go, and hopefully your audio is going to be working great now. So Tom, if you want to introduce John, I will turn it over to John.
Thank you very much, Lori. Yeah, thanks again, Tammy, for the presentation. Our next speaker is John Gawlowski. John is Manitoba Agriculture's entomologist, and today he'll be speaking on early season insect ID, scouting in horticulture crops. Here's John.
Okay, thanks, Tom. So as Tom mentioned, the focus is going to be insect ID and scouting. However, I'm going to throw in a fair amount of information on control into this as well. Before I get into that, I always like to remind people at Hort School that insects aren't necessarily always our enemy. There are certain ones we'd rather not have, but being hort growers, people growing fruits and vegetables, you need insects in some of those crops. You need the pollination, and of course there's a lot of good insects eating bad insects and doing lots of good things on your farm or in your garden. So the big challenge is really, how do we deal with the, I guess, less favorable ones while protecting the ones we want? And I'm going to try to cover that as well and go over some, I guess, selective or semi-selective ways of dealing with some of the pest insects. And I'm going to focus on 4 of them today: flea beetles, diamondback moth, both of which are cruciferous specialists. So those are things that will be feeding on your cabbage, broccoli, cauliflower, those crops. And then I'll cover a couple of generalists, cutworms and grasshoppers, give you a bit of an update on what we're seeing and what you should be looking for. Now in Manitoba, when we look at the landscape over the summer, there is no shortage of cruciferous plants. There is canola grown quite abundantly, and you don't have to go too far to run into a field that has some sort of cruciferous plant in it. So because of that, we're never going to be starving out our flea beetles, our diamondback moths, things that feed specifically on crucifer crops. They have an abundance of food, and dealing with them can sometimes be quite a challenge. And when we talk about flea beetles, first of all, we've got 72 different species of flea beetles in Manitoba. Some feed on your cruciferous vegetables, some feed on things like potatoes. There's quite a few species that feed on just non-economical plants. And there's even some good flea beetles. I'll show you one of these a little later that feed on nothing but weeds. So mixed bag when it comes to flea beetles. But the one that crucifer growers need to worry about are the striped flea beetles. So at the top of the screen, or the top of the picture rather, are a couple of 2 striped flea beetles, black, but they've got 2 yellow stripes down the back. And at the bottom is a crucifer flea beetle, solid black. These are the 2 more common ones in your cruciferous vegetables. And as you can see, they make little pits in cotyledons and the young leaves. They don't usually take big chunks out of plant tissue. It's just little pits that they make that dry out. And if you have enough of this type of feeding, the plants struggle. And also there's the aesthetic part of it. If you're growing cabbage or something, you don't want to see pits all over your seedlings or your larger plants. Now, dealing with flea beetles can be a real challenge. There's not a lot of cultural controls. One thing that you can try is using transplants instead of direct seeding. Basically, you're trying to get the crop off to a good start, and a bigger plant going in might mean less flea beetle injury. So transplants might be more effective than direct seeding. We often see when plants are just coming out of the ground and they've got just cotyledons or 1 true leaf, that's when the flea beetles can do their most damage. Usually once you have 3 to 4 true leaves on a plant, the plants can compensate a lot easier than in those earlier stages. The other thing that can work is floating row covers. Now this might not be practical for a lot of people. Bigger operations, there's probably not the same potential, but backyard garden situations, maybe some smaller patches of cruciferous vegetables, floating row covers might be an option just to keep the flea beetles off during the more vulnerable stages. If you're using these, just make sure they're secured well and you're not actually trapping flea beetles onto your plants, that you're keeping them off. And there's several different insecticide options, and we'll go over a few of those in a moment. As far as scouting, there's different recommendations that are available depending on where you look. But the ones I'm going to present are what Ontario is using. Also, New York State and a few of the northern states use the same recommendations. And that's to inspect 25 plants and just get an estimation of what the flea beetle populations are like. And the threshold they use is up to the 6th leaf stage, that plants can tolerate no more than 1 flea beetle per plant. Now that seems like a very low threshold. In canola, we can tolerate a bit more than that. We tell our growers in canola roughly 25% defoliation as a threshold. Cruciferous vegetables, a bit more susceptible, and there's other considerations. So the threshold is actually fairly low. As far as what you can do with insecticides, there's several to choose from. These are all foliar sprays. And when I talk about insecticides, anything I have in green is an option for organic growers. Now, the products we have for flea beetles on cruciferous vegetables generally are all broad spectrum, meaning there's not much selectivity. So if you spray them, you're probably killing most of what's in the field. The one exception to that might be the Success and Entrust, which on the label it says suppression of flea beetles. These are, I'll call them semi-selective products. So they work to some degree on beetles. They are less toxic to some of the predators that would be in the field than some of the other products. They still are quite toxic to bees, though. So there's really no bee-friendly option in this group of products. So even if you're using Success or Entrust, if there's any, say, flowering weeds or anything in the field or any flowering plants around, be careful because these will kill bees in addition to what you're trying to target. And I mentioned that there can be good flea beetles as well. Here's an example of one. This is a spurge flea beetle. There's actually 3 different species of spurge flea beetles in Manitoba. They've all been introduced. And as the name might imply, they feed on nothing but leafy spurge, which is an invasive weed. That's why they were purposely introduced. So these won't feed on your cabbage or your broccoli. They just feed on spurge. They're good. So didn't want to leave flea beetles with just a bad name. There are some good ones as well. And we'll move on to Diamondback Moth. So another pest that feeds just on cruciferous plants. And they are a small green caterpillar. For people growing cruciferous vegetables, you're probably familiar with at least 2 or 3 different types of green caterpillars that feed on your crop. This will be the smallest of that batch. They don't get too big, just a little over 1 centimeter really. You can see if you look really carefully, a bit of a forked tail to them. And if you disturb them, they kind of go snaky and then they drop on a thread. That's Diamondback Moth. So they'll make chunks in your cruciferous vegetables. The first stage is actually a leaf miner, so they make little mines. And then after that, they start taking chunks out of your plant. Now, we do a monitoring program in Manitoba every year to try to determine what populations are like and where crops might be more at risk. Now, we're doing this for the canola growers, but people growing cruciferous vegetables, you could tap into this information and use it to help with your decision making as well. And we usually have about 80 or 90 of these delta traps set up, usually in canola fields. There's a lure that we put in that draws the males in. The lure smells like the same chemical the females use to attract the males during mating time. So the males are flying in looking for this female. They get stuck to a sticky bottom in the trap. So we lure them to our death, and then we count the inserts once a week, and we can try to predict what the risk is in various regions. And here are the trap counts as of today, around noon actually. And anybody in Western Manitoba, good news, the highest trap in the West anywhere so far is 14 in the paw. For this time of year, these are low numbers. Central region, we've got one high trap, that's in the Gladstone area, a bit of an outlier there. The highest counts so far have been in the East and the Interlake, but again, these aren't really exceptionally high counts. It means that the population did get blown in, they got dumped in the area, and we're waiting to see what develops. Diamondback moth doesn't overwinter here, they primarily blow in, so this is where the traps are helpful. They can tell us where these things have blown in and potentially could become established. Now, this data is all available on our Manitoba Ag and Resource Development website. It's updated twice weekly, so if you're interested in that, you can have a look. If you're having trouble finding the site, send me an email or give me a phone call, and I'll put you onto that data. Now, as far as chemicals for Diamondback moth go, there's quite a few that are registered. In fact, you've got more options than the canola growers do. There's a couple insecticides I'm going to highlight here, and they're ones that are selective to Lepidoptera. Lepidoptera is butterflies and moths. So these products kill caterpillars. They don't kill beetles, bees, ladybugs, damsel bugs, pirate bugs, any of your good guys. So they can be good choices. Dipel, BTK, they're basically formulated based on a bacteria that kills Lepidoptera. They are registered in organic systems, so if you're an organic grower, you can use these. But do take note, these kill the larvae, they do not kill adults. They're specifically larval insecticides. What they're doing is they're basically destroying the gut of the larva when they feed. And they will stop feeding quite quickly when they ingest the product. It might take a day or two to die, but they will eventually. And Trust, we saw this one in canola. Pretty good product on Lepidoptera. It's also organic, so it's available in cruciferous vegetables. The other one I'll highlight is Intrepid. Intrepid, I didn't put the insecticide group here, but it belongs to a group called the ecdysone receptor agonists. Ecdysone is a molting hormone, so for insects to grow, they have to shed their skeleton on the outside of their body, grow a little bit, and then they reform the skeleton. So what this product does is it messes up with that process. They can shed their skeleton, but when they start trying to regrow the skeleton, things get a little bit messy and they're just not too successful. They can't stop the molting process, basically, and they end up dying. So unsuccessful molt to the next stage. So it messes up with their system. It only targets Lepidoptera, though. It doesn't do this to bees and other bugs, beetles, lady beetles, so specifically Lepidoptera. So aside from cruciferous vegetables, if you're growing fruit crops and other vegetables where you need something that's not going to interfere with your pollinators or maybe beneficials you have established, but you want the diamondbacks or other caterpillars killed, Intrepid would be a good choice, as would Dipel or BTK. Now, I mentioned there's other caterpillars in cruciferous vegetables as well. Here's one of them, imported cabbage worm, much bigger green caterpillar, and you can see this kind of lemon yellow line going down the back of the body, kind of velvety green. This is insect that overwinters here, bigger green caterpillar. The products that work well on Diamondback moth would work well on these as well. So just to reiterate, small, green, not velvety, no yellow line, Diamondback moth, bigger, velvety, green, yellow line, imported cabbage worm. And there's one other caterpillar you sometimes might get called cabbage looper, about the same size as the imported cabbage worm, but when it walks, it loops. So easy ones to tell apart. So I'll go over the cutworms and grasshoppers fairly quickly, so we have time, hopefully, for a few questions. Cutworms, first of all, cutworms are not all alike. They do differ. In fact, we often categorize cutworms into 4 main groups. Subterranean, these are the ones that feed strictly underground. They don't come above ground much, so they're really hard to kill with insecticides. We have some that are surface feeders where they will come above ground. They like to feed right at the surface, and they often will cut plants. So you see a dead plant lying on the ground. We've got tunnel feeders that basically will clip plants, but they tend to pull them into a tunnel in the ground to chew on them. We don't have a lot of these in Manitoba. Black cutworm would be an example. It blows in, but we don't often see them in Manitoba. And then climbing cutworms, such as this dingy cutworm here, they will climb up onto the plants, take big chunks of them, and then go back into the soil during the day. So our primary ones in Manitoba tend to be, this year, redback cutworm is a dominant species, feeds along the surface, does a lot of clipping. Dingy cutworm, primarily surface, but they will climb on plants as well, do a lot of chewing, doesn't do a lot of clipping. Those are our two dominant species this year. They both do come above ground, and you can kill both with insecticides. So here's dingy cutworm. As far as ID goes, dingy cutworm, it almost looks like they have a set of tire tracks going down their back, a set of V's on the back. So if you see that, they're kind of a dull gray to brown color with tire tracks. That's dingy cutworm. Again, they will climb plants, take chunks of the plants, very rarely cut plants. They are very susceptible to insecticides. And the other common one, redback cutworm, the name defines it quite nicely. A couple reddish lines going down the back. And they're a clipper. They will clip a lot of plants, so you'll see plants lying on the ground. These little things next to the cutworm, that's the pupa stage. When you're starting to dig up a lot of those, that means they're starting to turn to the pupa stage. They're done for the year. So it's a bit too late to be spraying for cutworms when they're turning into pupa. They're already wrapping up their damaging stage for the year. Now, right now, most of the samples and photos I'm seeing come in, probably about the 4th or 5th out of their 6 larval stages. So they probably do have another stage or 2 to go in most fields. In another week or so, we'll probably start to see the pupa, and probably within another couple weeks, we'll be getting out of the period where cutworms are a major threat. But probably for another week or 2, you want to watch your fields quite well. And do note when you're scouting that during the day, the cutworms are going to be in the soil. They come out at night to feed. So if you're scouting during the day, do dig around the damaged plants and look for those cutworms. And if you do need to control them, a few tips. Cutworms can be very patchy. Sometimes you only need to be spraying patches, not whole fields. And if you have the choice, do your spraying later in the day or in the evening. That's when they're surfacing, and making good contact with them if you can is always a good thing, or at least having the chemical fresh on the plants closer to when they come out. That's also helpful. Also note that if you are poking around a day or 2 after you sprayed and you find the odd live cutworm, that's not totally unexpected. I mentioned earlier that insects go through molts where they change from one stage to the next. When they're going through a molt, they stop feeding for a couple days. They kind of clean their gut out, then they shed their cuticle. They have to reform that cuticle, and then they will start growing and feeding again. During that day or 2 where they're going through the molt, they are not feeding. They will not be ingesting the insecticide, so they may still be alive. Once they do resume feeding, the products that are registered have enough residual that they will be killing the cutworms still. I'm going to wrap up with grasshoppers. I'll go over this one quickly. Just to note, we have pest grasshoppers, we have non-pest grasshoppers. We actually have a lot more non-pest grasshoppers in Manitoba than we have pest species. The one on your right, these are katydids. They're a non-pest type. The one on your left is a 2-striped grasshopper. That's the most common one we saw last year. And based on the juveniles that we've seen this year around Carmen, I think it'll be the more common one for this year as well. Out of about 85 species of grasshoppers in Manitoba, we have 4 we consider pest species. Unfortunately, the ones that are most abundant tend to be the pest ones. Grasshoppers overwinter as eggs, so on your upper left, those are grasshopper eggs. They look like grains of brown rice, and they're usually in clumps of about 20 or 30 or more. So if you start seeing those when you're digging around in the soil, that's grasshopper eggs. We were out a couple of days ago looking in the ditches, and we could just start to see the grasshoppers hatching. Right now, they're just a few millimeters long. They're about the size of a wheat kernel, first instars. Hatch has just started. We've got a long ways to go yet before hatch is even done. But it's a good time to start looking. If you're trying to time a spray for grasshoppers, if you notice any very abundant populations, when they start getting their wing buds, like this grasshopper in the lower right, that's the ideal timing. When they start getting wing buds, probably the hatch is almost complete. They're not adults yet. They can't fly. They're probably still quite concentrated, easier to kill. Once they get to be adults, they are moving around, and they're also much harder to kill. So probably late June, early July, good time to be doing your grasshopper treatments if you need to. Regarding what to use, you've got lots of options. One thing that is registered for grasshoppers that is quite selective is a brand bait called EcoBrand. It's basically carbaryl put onto brand pellets. This has to be spread, not sprayed. The company that makes it, they also sell spreaders, conveniently enough. And if you're interested in this option, contact me. I can put you in touch with the company. There's several places in Manitoba that carry the bait. Some of the municipalities use it as well for the roadsides. Nolo bait is also a bait. If you use this one, though, be aware it's based on a protozoan called Nosema locustae, which makes the grasshoppers sick. They eventually die. This one is not quick acting. You're basically trying to knock them back in the long term using Nolo bait, whereas EcoBrand, once they ingest the bait, they're dead pretty quickly. Coragen, it's a semi-selective product, great on grasshoppers, great on Lepidoptera. Doesn't work with a darn on any Hymenoptera, so it's pretty safe for bees and parasitic wasps. So if you're, again, spraying an area where you're worried about if there's any flowering plants, whether it's weeds or crops in the area that you're spraying, I'd suggest considering either EcoBrand or Coragen. Both are quite selective, won't harm bees. The rest of these products, all very broad spectrum. They would be harmful to bees and any other insects in the area. And just to end with, regarding grasshoppers, some research that I've been talking about over the last couple of years, a study done in Wyoming, where they were trying to look for more economical ways to treat grasshoppers. And they did this work in rangelands. What they did was they went and they treated 100 feet, left the next 100 untreated, treated the next 100, etc. And they wanted to see what kind of control can we get doing this with different products. And what they found when they used carbaryl, which is 7, and they treated 100% of the rangeland, they got 94% kill, really good. When they treated 50% of the rangeland, they got 81% control. Lower, but still quite acceptable, and half the cost. When they did the same thing with malathion, virtually no difference in control. Now here they treated either 100 or 80% of the crop. They picked a really high residual product called fipronil, which we don't have here. Probably the closest thing we have for residual would be something like Coragen. But with this product, they treated either the whole rangeland or 1/3. Control went down from 98 to 92%. Again, very acceptable, but a fraction of the cost. I know people were trying this in some of the field crops last year. Anecdotally, people told me they thought they got good results. I'm trying to encourage people to do some research on this in field crops. It'd be nice to have some research in vegetable crops as well. But I wanted to throw that out just in case you're looking for ways to control grasshoppers and still keep things as economical as possible. And aside from the grasshopper control advantage, what you are doing is at least conserving pockets of biocontrol using this approach, which can help in the long term as well. This may not be practical in a lot of situations. It might be something you might want to consider in other situations. And if you start seeing this later in the summer, this is good. This is a grasshopper clinging to the tip of a canola pod. If we get heavy rains and some damp weather, there's a fungus called Entomophagous grilli that can get into the population and start killing them. It's kind of cool. The grasshoppers die clinging to the top of the plant. Eventually, their cuticle splits open, and the fungal spores will start coming out, and being high in the canopy, they can infect other grasshoppers. So we have to hope for a little bit of rain at least to get this fungus going in the population. And I'll just mention that if you're interested in more information on anything I've covered, we do have fact sheets on all of these insects on our website, so you can check that out, or give me a call and I'll put you onto this, and we can get you the information you need. And just to summarize, some insects are good, some you want to control. This year, flea beetles, high levels, be scouting for them, and be prepared to control them if needed. Cutworms are also an issue this year for many growers, so that's something else you want to be scouting for. Grasshoppers, it's too early to call yet, but just judging by what we're seeing right now, what people are reporting, there's a lot of first instars out there, and if we get another very dry year, this is something you'll also want to be watching for as well. So I'll end with that, and hopefully we've got time for a question or two.
We do have a couple here, John. We're going to leave your presentation open while we go through the questions for you. So you kind of answered that last one with the grasshoppers, but I'm going to ask it anyway. If we were to get some heavy rains in the next week, what impact could that have on grasshopper and cutworm populations?
Yeah, that's a super question. Now, very heavy rains probably aren't good in some regards for growers right now, but that's the one thing that could really knock the grasshopper populations back. With grasshoppers, if we're going to really set the populations back, we need a lot of moisture during the early instar nip stages. The eggs are resistant to water. You can put grasshopper eggs in a glass of water and leave them there for a week. They'll still hatch. A colleague of mine tried that just to prove it. The first instar nymphs, right when they hatch, are very vulnerable to excessive moisture. Heavy pounding rains will kill them, and if they don't get killed, they're much more vulnerable to disease. So heavy pounding rains within the next week or two that accumulate, that could be bad news for the grasshoppers. That could set them back. For cutworms, they don't like too much rain either. They're more susceptible to both predators because they're up near the soil surface more, and fungal pathogens. So neither of them really like excessive rainfall this time of year too much.
Excellent, thanks. So with that comment on cutworms, how far down in the soil do you have to look to find cutworms?
So cutworms usually like to hang out around the moisture line. So young cutworms like to be quite high in the soil if they can. So they're usually about a centimeter down in the soil, or even higher sometimes. The older cutworms, they will go as far as they need to get moisture. So if the soil is very moist, they might be just a centimeter or so down in the soil. If the soil starts to dry out, a study done in Ontario with dark-sided cutworm, they were finding them 3 to 4 inches, or a good 10 centimeters down into the soil when the soil became drier. So moist soils, you probably don't have to dig too deep, but if the soils are quite dry, you might have to be going 3 to 4 centimeters down into the soil to find the cutworms.
Okay, great. And while I have you on, I'll finish with your questions. So are there resistant issues for insecticide tolerance in flea beetles?
Not that we're aware of, and it actually surprises me because with the canola growers, they've been using the neonicotinoids for a long time now. It's been roughly 20 years now since the neonics came on the market. So it wouldn't be surprising if there started to become some resistance. It's not being well studied right now, so we do need more research on that. The one thing that is confusing, though, there was research done fairly recently showing that striped flea beetles aren't as susceptible to the neonics as crucifer flea beetles. Now, this isn't resistance because there's been no genetic change in the beetles. They just aren't killed as well by the neonics. And I think the people that know of that research, I've heard before people make the claim that the striped flea beetles are becoming resistant. It's not really resistance, it's just they have better tolerance to the product, which is different than resistance.
Okay, so for growers who may spray and get poor control, what are possible explanations?
one of the explanations could be the products you're using and when you sprayed. If you're using a popular group for flea beetles are the pyrethroids, so things like Desis, Matador, Pounce. Those products do have some temperature restrictions on them, so pay attention to that. Don't be spraying on extremely hot days with those products. So that's one possible explanation. Flea beetles are also very mobile, and we've seen this with the canola growers quite a bit, where they will spray and it looks like things have been controlled, and then a few days later the field is just full of flea beetles again. This time of year they're moving around quite a bit. They're quite active. It could be reinvading populations coming into the field.
Okay, great. And the last one for you, John, is any suggestion for a suitable insecticide to deal with cutworms and cucurbits?
Yeah, okay, good question. There's a lot of things that work. Now, again, if you're wanting something that's a bit more on the selective side, Coragen is registered, actually in a lot of vegetable crops for cutworms. Good choice, good residual, somewhat selective. It's a bit more expensive than your pyrethroids. The pyrethroids, again, your products like your Pounce, your Desis, they do work quite well. Not as selective, cheaper. So those are a couple of the groups that, again, depending on what you're trying to accomplish, you could consider.
Okay, great. Okay, so I'm going to go to Tammy now. There's 3 questions for Tammy that are kind of all the same, so I'm going to kind of put them all together. And they're basically, what is the best way to clean? What's the best product to use to rinse out your sprayer tank? And what is the best way to minimize contamination in that sprayer tank?
Okay, so because we're a little bit over time, I'm going to keep this really short. On pages 12 and 13 of the Guide to Crop Protection, or the Field Crop Protection 2020, whatever it's called, there is a lot of information about sprayer cleanout. It really depends on the herbicide or the pesticide. And so look at the label, it'll tell you whether to use ammonia, water, or a detergent. Depending on that, you can make a selection. For ammonia, there are things like flush or finish. For detergent risks, you're looking at something like all clear or a non-ionic surfactant that can be used instead. You still need to do triple rinsing, get lots of water through there as well. Make sure that there's no hang up in your nozzle or any other parts that could be contaminated. And sometimes leaving it overnight with water in that sprayer tank will help to pull some of the stuff that's stuck into the plastic tank out into solution and get rid of it as well. So that's the short version.
Okay, thanks. And Colleen, there was, I'm not sure if it's more of a comment than a question you might want to comment on. So testing is extremely expensive and applicators are not always cooperative.
Yeah, well, I'm not quite sure what to say about that one. Testing
Okay.
can be expensive, but sometimes it's important and it would be useful to have that information. Other times there's not much that can be done, maybe looking at the visual and going from there. Applicators, it depends on the applicator, obviously. If you can open up, I guess what I could really stress is open up the lines of communication. Try and talk with the applicators, try and communicate with them, and just keeping that line of communication open is really important and can prevent a lot of incidents. Lori, I just had one other comment to make though, separate to that question. There was one point that was not in my slide, but I do want to mention it, that the importance of contacting mask in regards to chemical drift. So like yield losses caused by third parties such as chemical spray drift are included as production for mask coverage calculation purposes, and just provided that the mask appraises the loss and the third party provides compensation for that loss. But I didn't directly speak about that, so I just wanted to mention that as well, so people are aware that the importance of contacting mask as well when there is a spray drift issue.
Excellent. Well, thank you very much for that. Okay, Tom, that takes us to the end of the presentations and questions today, so I'll let you finish things up.
Well, thanks, Lori. I'd like to thank everyone that took the time out of their busy day to join today's webinar. Also, behind the scenes, Lori and Tracy for helping organize it, and our presenters, Colleen, Tammy, and John. This is the first of a series, first webinar in a series, and there's five remaining. The next one will be on Thursday, June 18th at 1:30, and it will be dealing with sweet potato production. So if you're interested in sweet potato production or know anyone that is, feel free to encourage either them or yourself to come and join the webinar. For those of you that are certified crop advisors and would like to receive CCA credits, if you could email your CCA number to Tracy Cummer. Her email is on the slide in front of you there. Tracy with an E, tracey.cummery@gov.mb.ca. And we're done. Thank you very much.